Imagine standing on a distant shore, gazing at an alien sky with not one, but two suns casting their glow across a landscape unlike anything on Earth. The air is unfamiliar but breathable, and beneath your feet lies the soil of a world light years away from home. What if this could be humanity's future, a new Earth among the stars? With our planet facing mounting challenges, from dwindling resources to the ever-changing climate, the idea of finding a second home is no longer confined to the realm of science fiction. So, what distant worlds hold the promise of life or even a safe haven for us? Scientists have dedicated decades to unraveling this mystery, peering into the vastness of space to locate planets that could sustain life as we know it. These planets, known as potentially habitable exoplanets, spark our imagination and ignite humanity's greatest question: are we truly alone in the universe? In this video, we'll take you on a journey to explore 30 fascinating planets that scientists believe could be habitable. From rocky worlds brimming with potential oceans to distant planets orbiting dim red stars, each offers a unique glimpse into the possibilities that lie beyond our home planet. Prepare to embark on an exciting voyage through the wonders of space as we uncover the mysteries of these extraordinary worlds. Now turning to Proxima Centauri b, the closest known exoplanet in the habitable zone to Earth. This intriguing world orbits our nearest stellar neighbor, Proxima Centauri, a red dwarf star situated a mere 4 light-years away. Its remarkable proximity has made it a focal point of scientific study, offering a tantalizing opportunity to explore the possibility of life beyond our solar system without venturing too far into the cosmic expanse. Proxima Centauri b is roughly 1.3 times the mass of Earth, placing it in the category of Earth-like planets. This means its gravity could closely mirror what we experience on our home planet, a critical factor when considering human adaptability. Furthermore, it resides within the habitable zone of its star, the region where temperatures could potentially allow for the existence of liquid water, a key ingredient for life as we know it. However, the planet's surface conditions remain shrouded in mystery. While its location relative to its star suggests potential habitability, Proxima Centauri b's close orbit exposes it to intense stellar flares and ultraviolet radiation, which could pose challenges for sustaining an Earth-like atmosphere. Despite these hurdles, the prospect of Proxima Centauri b as a potential second home for humanity continues to captivate scientists and dreamers alike, as it represents one of our first and most accessible steps toward interstellar exploration. Moving forward, let us journey further into the cosmos to uncover other worlds that may harbor the spark of life. Now turning to Kepler 452b, often referred to as Earth's cousin. This fascinating exoplanet has captured the attention of scientists due to its striking similarities to our own world. Located approximately 1,400 light-years away in the Cygnus constellation, Kepler 452b is slightly larger than Earth, with a radius about 1.5 times that of our home planet. This size places it within the category of super-Earths, making it a prime candidate for further exploration. What makes Kepler 452b particularly intriguing is its location within the habitable zone of its parent star, a region where temperatures are just right for liquid water to potentially exist on its surface. Its host star, much like our Sun, is a G-type main sequence star, but the twist lies in its age. Kepler 452b's star is estimated to be around 6 billion years old, significantly older than our Sun, which is approximately 4.6 billion years old. This aging star provides a unique opportunity for scientists to study what conditions on Earth-like planets might look like in the distant future as their stars age and evolve. The extended time that Kepler 452b has had within the habitable zone suggests that if life ever developed there, it would have had billions of years to evolve, offering tantalizing possibilities about advanced or ancient forms of life. However, the planet's larger size and its slightly stronger gravity compared to Earth might pose challenges for human colonization. Even so, the parallels between Kepler 452b and Earth continue to inspire curiosity, as it stands as a potential glimpse into what our planet's future or distant cousins might hold. Let us now journey onward to explore the next fascinating world in our search for habitable planets. Moving forward, we arrive at TRAPPIST-1e, a remarkable exoplanet within the widely studied TRAPPIST-1 system, located approximately 40 light-years away in the Aquarius constellation. This system is unique, hosting 7 Earth-sized planets tightly orbiting a cool red dwarf star, and TRAPPIST-1e stands out as one of the most promising candidates for habitability. Slightly smaller than Earth, with about 92% of Earth's radius, this rocky planet resides comfortably in its star's habitable zone, where conditions might allow for liquid water to exist. Its moderate temperature, thanks to the relatively low energy output of its parent star, suggests a climate that could be suitable for supporting life. Another fascinating aspect is the potential for a thick atmosphere that might help regulate surface temperatures, an essential factor for creating stable conditions for life as we know it. Given the star's dim light and the planet's close proximity to it, days on TRAPPIST-1e may differ significantly from our own, with one side possibly locked in perpetual daylight and the other in darkness. However, scientific models suggest that a well-distributed atmosphere could evenly spread heat, reducing extreme temperature differences and making more of the surface habitable. What truly excites researchers about TRAPPIST-1e is its relative accessibility for future observation. Being part of a nearby system, it offers opportunities to study its atmosphere in detail with advanced telescopes, searching for biosignatures like oxygen or methane that could hint at life. As we continue our cosmic journey, TRAPPIST-1e shines as a fascinating world that captures both the imagination and scientific curiosity, urging us to keep probing deeper into the mysteries of the universe. Now turning to LHS 1140b, this intriguing celestial body has earned the title of a super-Earth because of its size and significant potential for habitability. Located approximately 48 light-years away in the Cetus constellation, this planet is about 1.4 times the size of Earth, making it larger but still retaining a rocky composition similar to our home planet. What sets LHS 1140b apart is its dense atmosphere, which scientists believe could include a high concentration of greenhouse gases. This atmospheric composition may help trap heat, maintaining surface temperatures that could allow for liquid water, an essential ingredient for life. Adding to its appeal, this planet orbits in the habitable zone of a red dwarf star, a region where conditions are neither too hot nor too cold, further increasing the likelihood of life-friendly environments. Imagine a world where vast oceans may stretch across its surface, fostering conditions suitable for both microbial and possibly more complex forms of life if they exist. LHS 1140b also benefits from its star's relatively calm nature, as red dwarf stars are often known for their volatile flares, but in this case the star appears quieter, reducing harmful radiation that could otherwise strip away the planet's atmosphere. This stability enhances its potential as a candidate for habitability. Scientists are particularly excited about this super-Earth because it offers a unique opportunity for detailed atmospheric studies. With upcoming advancements in telescope technology, researchers hope to detect atmospheric signatures like water vapor or carbon dioxide, which would provide further clues about its environment. The combination of its size, atmosphere, and location in the habitable zone makes LHS 1140b a standout candidate, captivating the imagination of scientists and space enthusiasts alike. As we journey further into the cosmos, this extraordinary planet reminds us of the countless possibilities that await discovery in the vast expanse of space. Now turning to Ross 128b, this remarkable exoplanet captures attention with its temperate climate and Earth-like mass, making it a strong contender for habitability. Located just 11 light-years away in the Virgo constellation, Ross 128b is one of the closest known exoplanets that could potentially support life. What makes this planet particularly intriguing is its orbit around a relatively quiet red dwarf star. Unlike many red dwarfs notorious for their intense and harmful stellar flares, Ross 128b's host star is notably calm. This stability significantly reduces the risk of harmful radiation stripping away the planet's atmosphere, thereby increasing the chances of it retaining the essential components needed for life to thrive. Positioned firmly within its star's habitable zone, Ross 128b enjoys surface temperatures that are likely neither too hot nor too cold, creating the possibility of liquid water, a critical ingredient for life as we know it. Its Earth-like mass further suggests a rocky composition similar to our own planet, which could provide the foundation for a stable surface environment. Scientists are particularly drawn to Ross 128b not only because of its favorable conditions but also due to its proximity to Earth, which allows for more detailed observations. With advancing technologies in space telescopes, researchers hope to analyze its atmosphere for traces of life supporting elements like water vapor, oxygen, or methane. These findings could provide groundbreaking insights into the potential for extraterrestrial life. Ross 128b serves as a powerful reminder that even relatively close to our own solar system, the universe holds tantalizing possibilities for worlds that might one day become humanity's second home. As we continue to explore the cosmos, this fascinating planet leaves us with much to envision and even more to discover. Moving forward, we arrive at Gliese 667cc, a fascinating exoplanet situated in the habitable zone of a unique triple-star system. Located approximately 23 light-years away in the constellation of Scorpius, Gliese 667cc has captured the imagination of scientists due to its intriguing characteristics. Its orbit places it at just the right distance from its primary star, a red dwarf, where conditions could allow liquid water to exist on its surface. This balance between receiving enough warmth but not overheating is vital in identifying potential habitats for life as we understand it. What makes Gliese 667cc even more compelling is its size. Classified as a super-Earth, it is at least 4 times the mass of our planet, strongly suggesting a rocky composition with a robust gravitational pull capable of maintaining a stable atmosphere. Such a rocky surface might provide the foundation needed for complex geological and potentially biological processes to occur. The presence of 3 stars in this system adds another layer of intrigue, offering dramatically unique nightscapes and possibly complex interactions between the stars and the planet's environment. Researchers are particularly curious about the potential climate and atmospheric conditions on Gliese 667cc, with many speculating that its rocky nature could support the kind of environments conducive to life. Being relatively close to Earth in cosmic terms also enhances its appeal, as it provides an excellent target for detailed observation with current and future space telescopes. As we peer deeper into the cosmos, Gliese 667cc reminds us of the extraordinary variety of environments that exist beyond our solar system and the persistent hope of finding a second cradle for life among the stars. Now turning to K2-18b, this exoplanet has ignited immense excitement in the scientific community, and for good reason. Located approximately 124 light-years away in the constellation of Leo, K2-18b orbits within the habitable zone of its red dwarf star, where temperatures could allow liquid water to exist. What sets K2-18b apart is the groundbreaking discovery of water vapor in its atmosphere, a finding that represents a significant leap forward in the search for potentially habitable worlds. This detection of water vapor has sparked new discussions about whether conditions on K2-18b could support life as we know it. The planet itself is classified as a super-Earth with a mass roughly 8 times that of Earth, suggesting a rocky or icy core enveloped by a thick, gaseous atmosphere. While this dense atmosphere poses challenges, scientists speculate that it might also create conditions suitable for life, particularly in regions where pressures and temperatures are moderate, akin to those found on Earth's surface. Another intriguing aspect of K2-18b is its potential to host a unique ecosystem within its clouds, where water droplets could interact with other elements, possibly creating a foundation for microbial life to thrive. Such possibilities make this planet a crucial target for future investigations. With advancements in observational technology, researchers are hopeful that we can gather even more detailed data about K2-18b's atmospheric composition, surface conditions, and overall environment. This exoplanet reminds us that the search for life beyond Earth is not confined to finding exact replicas of our world, but requires us to expand our understanding of where and how life might exist in a diverse universe. Moving forward, Wolf 1061c enters the spotlight as an intriguing candidate in the quest for habitable planets. Situated just 14 light-years away, this exoplanet resides in the habitable zone of its parent star, Wolf 1061, a red dwarf located in the constellation of Ophiuchus. Its close proximity to Earth makes it one of the best-studied exoplanets in our galactic neighborhood. Wolf 1061c is classified as a super-Earth with a mass approximately 4 times that of our planet. This size suggests a rocky composition, which increases its potential to support Earth-like conditions. However, one of the most fascinating aspects of Wolf 1061c is the possibility of tidal locking. Tidal locking occurs when one side of the planet continuously faces its star, resulting in permanent daylight on one side and perpetual darkness on the other. This unique phenomenon could cause extreme temperature variations across the planet, with one hemisphere intensely hot and the other bitterly cold. Yet, scientists speculate that in the twilight zone, the area between these two extremes, conditions might be more temperate, potentially allowing liquid water to exist. The challenge lies in understanding whether Wolf 1061c's atmosphere could redistribute heat effectively, a factor that would greatly influence its habitability. Despite these uncertainties, its closeness to Earth makes it an excellent target for future observations, offering an exciting opportunity to explore the complex interplay of factors that make a planet suitable for life. Wolf 1061c reminds us that the diversity of potential habitable worlds demands an open mind and a willingness to investigate environments vastly different from our own. Now turning to HD 40307g, we encounter another remarkable super-Earth in the search for habitable planets. Located approximately 42 light-years away in the constellation of Pictor, this exoplanet orbits a quiet orange dwarf star known as HD 40307. What sets HD 40307g apart is its stable orbit within the star's habitable zone, a region where temperatures could allow liquid water to exist on the surface. With a mass about 7 times that of Earth, HD 40307g is classified as a super-Earth, and its size suggests a rocky composition or a dense atmosphere, both of which are intriguing for scientists exploring its habitability. A stable orbit significantly enhances this planet's potential to maintain a consistent environment over long periods, giving any potential life forms the opportunity to adapt and thrive. Unlike planets orbiting more active stars, HD 40307g benefits from its parent star's calm nature, meaning it experiences minimal harmful radiation that could otherwise strip away its atmosphere or hinder the development of life. The planet's larger size and potential for a thick atmosphere could also play a vital role in sustaining life, as it may help regulate temperatures and protect the surface from extreme conditions. While much about HD 40307G remains speculative due to the vast distance separating us from it, its stable conditions and favorable location within the habitable zone make it an enticing candidate for future exploration. HD 40307G stands as a beacon of promise, reminding us that even in the quiet corners of the galaxy, the potential for life-sustaining worlds might still exist. Moving forward to Tau Ceti e, we explore a fascinating world nestled within the Tau Ceti system, a star system located just 12 light-years away in the constellation of Cetus. What makes Tau Ceti particularly intriguing is its strikingly Earth-like characteristics. This exoplanet resides in the habitable zone of its parent star, a region where temperatures could potentially allow liquid water to exist, a crucial ingredient for life as we know it. Tau Ceti e is slightly larger than Earth, which places it in the category of super-Earths, and its size suggests it could have a rocky surface or a substantial atmosphere that might support a stable climate. Adding to its allure is the Tau Ceti system itself, which is notably abundant in planets, offering scientists a rich environment for studying planetary formation and potential habitability. The parent star, Tau Ceti, is a quiet and long-lived star similar to our Sun, though slightly smaller and cooler. This calm nature reduces the risk of damaging solar flares or radiation, creating a more stable environment for any potential life forms on Tau Ceti e. However, challenges remain as this planet is on the inner edge of the habitable zone, which could mean higher temperatures depending on its atmosphere's composition. If its atmosphere can effectively regulate these temperatures, Tau Ceti e might sustain conditions suitable for life. The proximity of the Tau Ceti system to Earth makes it a prime candidate for further study, as future missions might be able to gather direct data about this intriguing world. Tau Ceti e stands as a testament to the diversity of potentially habitable planets in our cosmic neighborhood, sparking curiosity about what secrets it may hold. Now turning to Captain B, we delve into one of the most ancient exoplanets ever discovered. Orbiting a red dwarf star roughly 13 light-years away in the constellation of Pictor, Captain B stands out not only for its potential habitability but also for its astounding age. This planet is estimated to be around 11 billion years old, which is more than twice the age of our Earth and just a few billion years younger than the universe itself. Such an extraordinary timescale raises fascinating questions about the potential for life and the evolution of planetary systems over cosmic epochs. Captain B resides in the habitable zone of its star, where conditions might allow the presence of liquid water, a cornerstone for life as we know it. This world is categorized as a super-Earth due to its size being slightly more massive than our planet, which suggests a rocky composition and a stable surface that may foster life-friendly conditions. Its parent star, Captain Star, is a quiet and long-lived red dwarf, offering a relatively calm environment with minimal harmful radiation. However, one of the most intriguing aspects of Captain B lies in its cosmic history. Scientists believe that Captain B originated in a different galaxy that was later absorbed by our Milky Way, making it a traveler through space and time. This ancient and wandering past not only adds to its allure, but also provides a unique opportunity to study how environmental conditions might evolve on a habitable planet over billions of years. The potential for liquid water and its vast age make Captain B a captivating subject for further research, as it could hold clues about the resilience of life in the universe. Captain B reminds us that the story of our galaxy is far more complex and intertwined than we often imagine, sparking a deeper sense of wonder about what secrets such ancient worlds could reveal. Moving forward, we encounter one of the most debated candidates for habitability, Gliese 581g. Nestled approximately 20 light-years away in the Libra constellation, this planet has intrigued scientists and sparked heated discussions since its alleged discovery. What makes Gliese 581g so enigmatic is the uncertainty surrounding its very existence. Some researchers argue that the signals indicating its presence might simply be noise or data errors, while others are convinced that this planet is real and waiting to be understood. If its existence is confirmed, Gliese 581g would occupy a position in the habitable zone of its parent star, Gliese 581, a red dwarf that emits less heat and light than our Sun. This location is ideal for potentially sustaining liquid water on the planet's surface, one of the critical factors for life as we know it. Gliese 581g is believed to be a rocky world about 3 to 4 times as massive as Earth, classifying it as a super-Earth. Its size suggests it could have a substantial gravitational pull to hold onto an atmosphere, which might further enhance its habitability. The planet's orbit is also of interest as it is thought to be tidally locked, meaning one side of Gliese 581g would always face its star, basking in eternal daylight, while the other side would remain in perpetual darkness. This extreme contrast could give rise to a habitable twilight zone along the boundary where day meets night, offering moderate temperatures suitable for liquid water to exist. However, the debates about this planet's discovery have left its potential as a home for life shrouded in mystery. Gliese 581g stands as a reminder of how challenging and intricate the search for habitable worlds can be, highlighting the delicate balance between observation, interpretation, and evidence. Whether it truly exists or not, its story fuels our imagination and drives the relentless quest to uncover the secrets of distant worlds. Moving forward, we delve into the intriguing world of Gliese 832c, an exoplanet that has captured the attention of scientists for its remarkable Earth-like qualities. Located just 16 light-years away in the Gliese constellation, Gliese 832c is considered one of the most promising candidates for habitability close to our solar system. This super-Earth is approximately 5 times the mass of our planet, which likely grants it a strong gravitational pull capable of maintaining a stable and dense atmosphere. Such an atmosphere could play a crucial role in regulating temperatures and potentially supporting life. What makes Gliese 832c particularly fascinating, however, are the challenges posed by its orbital path. This planet follows an elliptical orbit around its red dwarf star, which means the distance between Gliese 832c and its star varies significantly over time. As a result, scientists believe the planet could experience extreme climate fluctuations, swinging between hot and cold periods depending on its position in the orbit. These temperature shifts might create diverse environmental conditions, with some regions possibly becoming more hospitable during specific phases of its orbit. Another intriguing aspect of Gliese 832c lies in its location within the inner edge of the habitable zone of its star. This positioning suggests that it might receive enough energy to support liquid water under the right atmospheric conditions. However, this proximity to its parent star also raises concerns about the intensity of stellar radiation, which could impact the planet's surface and atmosphere. Despite these uncertainties, the unique combination of Earth-like characteristics and environmental challenges makes Gliese 832c a compelling subject of study. Scientists continue to investigate its potential as a habitable world, knowing that its complexities might one day unlock valuable insights about the diverse possibilities for life beyond Earth. Now turning to Kepler 22b, we explore a groundbreaking discovery in the search for habitable worlds. Known as the first planet identified by the Kepler mission within the habitable zone, Kepler 22b has been a cornerstone in our understanding of planets beyond our solar system. Located around 600 light-years away, this exoplanet orbits a star strikingly similar to our own Sun, offering intriguing parallels to Earth's environment. Kepler 22b is roughly 2.5 times the size of Earth, placing it in the category of super-Earths, though its exact composition remains a subject of scientific inquiry. Some researchers speculate that it could be a rocky planet with a thick atmosphere, while others suggest it might be more akin to a mini Neptune with an ocean-covered surface. What makes its orbit particularly intriguing is its location right in the middle of the habitable zone, the sweet spot where temperatures could allow liquid water to exist on the surface. This optimal distance from its star provides Kepler 22b with a stable climate, free from the extremes often observed on other exoplanets. Its year, lasting about 290 days, is also quite similar to Earth's, further fueling interest in its potential to support life. Scientists are especially curious about the planet's atmosphere, as its composition could hold the key to its habitability. If the atmosphere is thick enough to create a greenhouse effect, it could maintain a temperature range suitable for liquid water and possibly life. However, the lack of detailed data about its surface and atmospheric conditions leaves many unanswered questions, making Kepler 22b a tantalizing mystery in our quest to understand habitable worlds. As we wait for future advancements in telescope technology to reveal more about this distant candidate, Kepler 22b remains a beacon of hope, symbolizing the potential for discovering habitable environments far beyond our solar system. Moving forward, we arrive at GJ 1214b, a planet that has captured the imagination of scientists and space enthusiasts alike. Nicknamed the Water World, this unique exoplanet is located approximately 40 light-years from Earth in the constellation Ophiuchus. What sets GJ 1214b apart is its dense atmosphere, which has led researchers to hypothesize that it may be enveloped in a vast ocean spanning its entire surface. Roughly 2.5 times the size of Earth, this super-Earth resides close to its host star, a dim red dwarf, completing an orbit in just 38 Earth days. While this proximity might suggest an inhospitable environment, the faintness of the star allows temperatures that could potentially support liquid water, provided the planet's atmospheric conditions are just right. The atmosphere itself is a subject of intense study as it appears thick, rich in hydrogen, and possibly containing water vapor, hinting at the presence of a steamy, oceanic world beneath. If true, the implications are staggering, as oceans are considered one of the most promising environments for the emergence of life. However, the thick atmosphere also raises questions about the planet's surface conditions. Could it harbor an exotic, high-pressure ocean, or is its surface a more alien terrain unlike anything we've seen before? Observations so far suggest a composition unlike Earth, indicating that GJ 1214b may represent a novel category of habitable worlds. As telescopes and observational technologies continue to evolve, scientists are eager to uncover the secrets of this mysterious water world, offering a glimpse into the diversity of potentially habitable planets in our galaxy. Now turning to HD 85512b, this intriguing exoplanet sits roughly 36 light-years away from Earth, nestled within the constellation of Vela. What makes HD 85512b particularly fascinating is its location at the very edge of its star's habitable zone, the delicate region where conditions might allow liquid water to exist on a planet's surface. Slightly larger than Earth, this super-Earth orbits an orange dwarf star which emits a gentler, more stable light than our Sun, potentially providing an environment conducive to life. Scientists speculate that the planet's surface temperature could support liquid water if specific atmospheric conditions, such as the presence of greenhouse gases, create a warming effect to stabilize its climate. Greenhouse gases like carbon dioxide or methane could act as a natural blanket, trapping enough heat to prevent the planet from freezing over. This possibility has sparked significant interest because on Earth, similar greenhouse effects are essential for maintaining temperatures suitable for life. However, much remains unknown about HD 85512b, including its atmospheric composition and whether it harbors the right balance of elements to sustain habitability. If its atmosphere is too thick or too thin, it could either trap excessive heat, leading to a greenhouse effect runaway, or fail to trap enough warmth, leaving the planet cold and barren. Researchers are eager to uncover more clues, as this planet sits at a critical point, representing the fine line between a potentially habitable world and one that falls short of supporting life. As technology advances, unraveling the mysteries of HD 85512b may not only teach us more about the factors that make a planet livable, but also expand our understanding of the diverse range of environments that might host life beyond our own world. Moving forward, we arrive at Gliese 163c, a fascinating world situated approximately 49 light-years away in the constellation of Dorado. Classified as a super-Earth, this exoplanet boasts a mass more than 6 times that of our own planet, making it significantly larger and more robust. Its size places it squarely in the category of planets that could potentially sustain a stable atmosphere, which is a critical factor for habitability. Gliese 163c orbits a red dwarf star at a relatively close distance, completing its orbit in just 26 days. Despite this proximity, it resides in what scientists believe is the habitable zone, where temperatures might allow for the presence of liquid water. Red dwarf stars, while smaller and cooler than our Sun, often offer extended periods of stability, which could provide a consistent environment for life to potentially take root. However, the planet's greater size introduces its own set of questions. Could its stronger gravity retain an atmosphere that supports life, or would it create conditions too harsh for survival as we understand it? The answers to these questions hinge on the planet's atmospheric composition and surface conditions, which remain a mystery for now. With telescopes continually improving, researchers hope to uncover more about this enigmatic giant, particularly whether its size and location combine to create a temperate world or one that is inhospitable despite its promising qualities. Gliese 163c represents another piece of the vast and complex puzzle of uncovering worlds that might one day support life, keeping it firmly in the sights of astrobiologists and astronomers alike. With the next phase of the journey in sight, we now explore Kepler 62f, an extraordinary planet nestled within the captivating Kepler 62 system, situated approximately 1,200 light-years away in the constellation of Lyra. This planet has drawn considerable attention from scientists due to its position in its star's habitable zone, the region where conditions could allow liquid water to exist on the surface. Kepler 62f is slightly larger than Earth, with a radius about 40% greater, leading researchers to believe it is likely rocky in composition, much like our own planet. Its host star, a smaller and cooler type known as a K-dwarf, emits less intense radiation compared to our Sun, but this is compensated by Kepler 62f's closer orbit, ensuring it receives adequate energy to potentially support a temperate climate. What makes this planet particularly intriguing is its potential for retaining a stable atmosphere, a crucial factor in fostering conditions favorable for life. While the exact details of its surface and atmospheric composition remain unknown, simulations suggest that if Kepler 62f possesses an atmosphere rich in carbon dioxide, it could have the right balance to maintain a mild, habitable environment. The discovery of such a planet underscores the diversity of exoplanets within other star systems, as well as the tantalizing possibility that life could exist beyond Earth. Kepler 62f stands as a beacon of hope in the ongoing search for habitable worlds, inviting us to imagine what secrets it might hold as we continue to refine our tools and expand our understanding of the universe. Now turning to Kepler 186f, a planet often hailed as Earth's twin for its striking similarities in size and location within its star's habitable zone. This remarkable world orbits a faint red dwarf star approximately 500 light-years away in the constellation of Cygnus. What makes Kepler 186f historically significant is its designation as the first Earth-sized planet to ever be discovered in a star's habitable zone, marking a monumental milestone in the search for potentially habitable exoplanets. Its radius is almost identical to Earth's, which strongly suggests it could have a rocky composition. Kepler 186f resides on the outer edge of its star's habitable zone, a region where temperatures might allow liquid water to exist on its surface under the right atmospheric conditions. Since red dwarf stars are smaller and cooler than our Sun, the planet must orbit much closer to its star to receive sufficient warmth, resulting in a year that lasts only 130 Earth days. Despite its close proximity, Kepler 186f's position in the star's habitable zone presents the exciting possibility of a temperate climate. What sets this planet apart is its potential to host conditions favorable for liquid water, a key ingredient for life as we know it. However, its exact atmosphere remains unknown, and further studies are needed to determine whether it can maintain the stability required to support life. Kepler 186f's discovery has inspired a deeper exploration of Earth-sized worlds around red dwarf stars, opening new avenues in the quest to find planets that might just be capable of sustaining life. Moving forward to Gliese 581d, a planet that has sparked considerable interest due to its intriguing position near the outer edge of its star's habitable zone. Gliese 581d, located approximately 20 light-years away in the constellation Libra, orbits a red dwarf star. This star is smaller and cooler than our Sun, which means its habitable zone lies much closer to the star compared to our solar system. What makes Gliese 581d particularly fascinating is the strong scientific belief that it possesses a thick atmosphere, which could potentially sustain liquid water on its surface. Such an atmosphere might act as a protective blanket, trapping heat and creating conditions suitable for maintaining a temperate climate despite the planet's location on the colder edge of the habitable zone. This makes Gliese 581d a promising candidate for hosting environments that might support life. Its size, being several times the mass of Earth, suggests it could be a rocky super-Earth or a planet with a significant water content. While much about this distant world remains uncertain, the possibility of a stable atmosphere capable of supporting liquid water has fueled ongoing research and speculation. Gliese 581d serves as an inspiring example of how planets on the outer reaches of habitable zones may still hold the potential for life, encouraging scientists to broaden the criteria used in the search for habitable worlds. Now turning to Kepler 1649c, a planet often referred to as Earth's mirror due to its remarkable resemblance to our own world. Located over 300 light-years away in the constellation Cygnus, this exoplanet shares many key characteristics with Earth, making it a standout candidate in the search for potentially habitable planets. Kepler 1649c is almost identical in size to Earth, suggesting a similar gravitational pull that could support an Earth-like atmosphere. What is even more intriguing is its location within the habitable zone of a red dwarf star, where conditions could allow liquid water to exist on its surface. The temperature on Kepler 1649c is estimated to be quite comparable to Earth's, further enhancing its status as a top contender for habitability. Its orbit around its star closely mirrors the relationship between Earth and the Sun, offering a balance of warmth and energy that researchers believe is crucial for sustaining life. The striking similarities have led scientists to call it one of the most promising discoveries for finding an Earth-like environment in space. While much about its surface conditions remains to be explored, Kepler 1649c fuels the hope that there are other worlds out there capable of supporting life as we know it. As research continues, this planet remains a captivating example of how far-reaching the possibilities are when it comes to identifying Earth's cosmic twin. Moving forward, we arrive at Kepler 442b, a fascinating exoplanet that has captured the attention of scientists worldwide. Located over 1,100 light-years away in the constellation Lyra, this planet stands out due to its rocky composition and placement in an ideal habitable zone. Kepler 442b is roughly one-third larger than Earth, which suggests it could have a solid, rocky surface, much like our own planet. Its orbit around an orange dwarf star offers just the right amount of energy to potentially sustain liquid water, a key ingredient for life as we know it. This star is cooler and smaller than our Sun, but its stable output provides a consistent environment that strengthens the case for habitability. What adds to its intrigue is the balance between the planet's size, distance from its star, and conditions within the habitable zone, all aligning to make it one of the most promising candidates for hosting life. Scientists are particularly interested in Kepler 442b because it combines Earth-like traits with unique features that could help broaden our understanding of what makes a planet livable. The immense distance poses challenges for deeper study, but as technology advances, researchers hope to uncover more about its atmosphere, surface conditions, and the possibility that it harbors life. Kepler 442b remains a shining example of how diverse and extraordinary habitable zone planets can be, sparking curiosity about what secrets it might hold. Now turning to Gliese 667 CF, we encounter a planet shrouded in mystery and scientific intrigue. This exoplanet resides in the fascinating triple star system of Gliese 667, located about 23 light-years away in the constellation Scorpius. What makes Gliese 667 CF so compelling is its potential position within the habitable zone of one of its stars, suggesting conditions that could support liquid water. It is classified as a super-Earth, meaning it is larger than our planet but still small enough to possibly have a rocky surface. Scientists estimate that Gliese 667 CF could be at least 4.5 times the mass of Earth, a size that might allow it to retain an atmosphere capable of regulating surface temperatures. The planet's orbit around its host star is particularly intriguing because of its stability and the energy it receives, which lies within the range considered favorable for habitability. However, due to the complexity of its star system, researchers continue to debate the specifics of its environment. The interplay of gravitational forces from the three stars might influence factors like tidal heating or atmospheric retention, adding layers of complexity to our understanding of this planet. While direct observations remain limited, Gliese 667 CF sparks immense curiosity as scientists refine models to predict its surface conditions and atmospheric composition. This enigmatic world underscores how even nearby exoplanets hold profound secrets, challenging us to push the boundaries of exploration and discovery. Moving forward, we arrive at Gliese 273b, a planet that has captured the imagination of scientists and enthusiasts alike. Located just 12 light-years away in the constellation Canis Minor, this exoplanet stands out not only for its proximity to Earth, but also for its role in groundbreaking scientific experiments. Gliese 273b orbits within the habitable zone of its red dwarf star, a region where conditions might allow for liquid water to exist on its surface. This makes it a fascinating candidate for habitability. What truly elevates its intrigue is its involvement in messaging extraterrestrial intelligence projects, where scientists have intentionally sent signals toward this planet in hopes of establishing contact with potential extraterrestrial civilizations. These transmissions, sent in the form of mathematical and scientific messages, aim to bridge the interstellar gap and spark responses that could transform our understanding of life in the universe. As a super-Earth roughly twice the size of our planet, it is thought to possess a rocky composition and possibly an atmosphere capable of supporting life. Researchers are particularly interested in studying its star, as red dwarfs are known for their longevity, but also for the potential bursts of stellar activity that could impact a planet's habitability. Gliese 273b represents a unique blend of scientific curiosity and ambition, inviting us to not only explore its physical characteristics, but also to consider the profound implications of reaching out across the cosmos. This planet stands as a symbol of humanity's relentless quest to connect with the unknown, expanding our horizons both scientifically and philosophically. With the next phase of the journey in sight, we shift our focus to TRAPPIST-1d, a planet nestled within the renowned TRAPPIST-1 system. This extraordinary system, located around 40 light-years away in the constellation Aquarius, has captivated scientists due to its remarkable configuration of 7 Earth-sized planets orbiting a single ultra-cool dwarf star. Among these planetary siblings, TRAPPIST-1d stands out as a particularly intriguing candidate for habitability due to its location within the system's habitable zone, where conditions might allow for liquid water to exist. What makes TRAPPIST-1d especially fascinating is its moderate temperature range, which suggests a climate that could potentially support a stable environment. Scientists have estimated that its proximity to its star and its size, slightly smaller than Earth, might contribute to creating an atmospheric balance suitable for life. Additionally, TRAPPIST-1d's compact orbit around its small, dim star reduces the risks associated with extreme stellar radiation, a common concern for planets orbiting red dwarf stars. This unique system, with its tightly packed planets, also presents a rare opportunity to study planetary interactions and their effects on habitability. Researchers are particularly excited by the possibility of comparing TRAPPIST-1d with its neighboring planets in the same system, as these comparisons could provide valuable insights into how planetary environments evolve and what factors are most critical for sustaining life. TRAPPIST-1d symbolizes the potential of finding habitable worlds not just as isolated discoveries, but as part of dynamic, interconnected systems, pushing the boundaries of our understanding of life beyond Earth. Moving forward, our exploration brings us to Kepler 1652b, a planet that has quickly garnered attention within the scientific community for its compelling characteristics. Kepler 1652b is located in a habitable zone where conditions might allow for liquid water, a fundamental ingredient for life as we understand it. Slightly larger than Earth, this planet's size places it in the category known as super-Earths, making it a promising contender for maintaining a stable atmosphere capable of supporting life. Its distance from its host star, a red dwarf, indicates it receives just the right amount of light and heat to sustain moderate temperatures, avoiding the extremes that often challenge planetary habitability. What makes Kepler 1652b even more exciting is the recent analysis of its atmospheric composition, which suggests the potential for conditions conducive to extraterrestrial life. Scientists are particularly intrigued by its ability to possibly retain water vapor, a key factor in creating a life-friendly environment. Adding to its allure, Kepler 1652b's location within its star system minimizes the risks of intense radiation, a critical advantage compared to many other exoplanets orbiting red dwarfs. This discovery underscores the diversity of worlds that could harbor life, reminding us that planets like Kepler 1652b may not only offer clues about their potential habitability, but also deepen our understanding of the incredible variety within the universe. As we examine these distant worlds, each new finding builds anticipation for the possibility of one day identifying life beyond Earth. With the next phase of the journey in sight, we arrive at Tegodon b, a planet that stands out as one of the closest potentially habitable worlds to Earth. Located just 12 light-years away, its proximity alone has made it a focal point of astronomical research. Tegodon b orbits within the habitable zone of its small, cool red dwarf star, where surface temperatures could allow liquid water to exist, a vital criterion for sustaining life as we know it. What sets Teegardens B apart is its remarkable similarity to Earth in terms of size and estimated surface conditions, suggesting it could have an Earth-like gravity that might support an atmosphere. Furthermore, its orbital period of just a few days highlights an intriguing aspect of its interaction with its host star, as the red dwarf's cooler nature provides the planet with stable, consistent heat without the intense radiation commonly associated with such stars. One of the most compelling aspects of Teegardens B is the potential for it to have a rocky surface, raising the possibility of complex geological processes that could contribute to a life-supporting environment. Its discovery has sparked significant excitement in the scientific community, representing a tangible example of just how nearby potentially habitable worlds might be. Teegardens B not only fuels our collective imagination, but also showcases how advances in observational technology bring us ever closer to finding a true second home. Moving forward, we now set our sights on Gliese 581c, a planet that has long been the subject of intense debate and fascination within the scientific community. Located approximately 20 light-years from Earth in the Libra constellation, Gliese 581c orbits within the habitable zone of its red dwarf star. This placement has sparked considerable interest as it suggests the planet might have conditions suitable for liquid water, a critical ingredient for life. However, much of the intrigue surrounding Gliese 581c lies in its atmosphere, or rather, the uncertainty of its atmospheric composition. Some scientists propose that the planet could have a dense atmosphere capable of creating a greenhouse effect, which might allow for surface temperatures warm enough to sustain liquid water. Others, however, caution that the same greenhouse effect could lead to extremely high temperatures, rendering the planet inhospitable. Adding to the mystery is Gliese 581c's position relative to its star, which suggests it could be tidally locked. This means one side of the planet could be in perpetual daylight while the other remains in constant darkness, potentially creating dramatic climate contrasts. Despite these challenges, the possibility of a narrow habitable band, a twilight zone where conditions might be just right for water to exist, keeps Gliese 581c at the forefront of exoplanet studies. Its discovery has not only ignited discussions about atmospheric science, but also emphasized how little we know about the complex interplay of factors that make a planet truly habitable. Gliese 581c serves as a reminder of the tantalizing balance required to foster life, fueling the ongoing search for planets that could one day expand our understanding of the universe. With the next phase of the journey in sight, we now explore Proxima Centauri c, a fascinating counterpart to the previously discussed Proxima Centauri b. Positioned in the same star system, this planet lies farther from its red dwarf star, placing it outside the traditional habitable zone. Unlike its closer neighbor, which enjoys a more temperate location, Proxima Centauri c's distance suggests it could experience much colder conditions. However, what makes this planet compelling to scientists is its classification as a super-Earth, meaning it is larger than Earth but smaller than the ice giants in our solar system. This size raises intriguing possibilities about its composition, as it could possess a rocky surface or perhaps even be an icy world with subsurface oceans. While less is known about its potential to support life, Proxima Centauri c's location and size make it an essential piece of the puzzle when examining the variety of planetary types within the same system. Additionally, studies of this distant world can help us understand how planets interact with their stars at varying distances and what conditions might arise as a result. Though it is not currently a leading candidate for habitability, Proxima Centauri c serves as a reminder that even planets outside the traditional habitable zone can offer valuable insights. Whether icy, rocky, or a mix of both, it remains a subject of close scrutiny as scientists continue to unravel the mysteries of the Proxima Centauri system. This dual exploration of two planets within the same system highlights the intricate dynamics at play, pushing the boundaries of what we consider possible in the search for life beyond Earth. With the next phase of the journey in sight, we now arrive at Lytton B, a planet that has captivated scientists with its location within the habitable zone of its red dwarf star. Lytton B stands out as a potentially promising candidate for habitability due to its size, which is slightly larger than Earth, earning it the classification of a super-Earth. This size suggests that it may share key similarities with our home planet, including the possibility of a rocky surface and conditions that could support life. What adds to the intrigue is its orbit around a relatively quiet red dwarf star. Unlike many stars of this type, which are known for volatile activity like intense solar flares, Lytton B's star exhibits a much calmer temperament, reducing the likelihood of harmful radiation that could otherwise strip away an atmosphere or hinder the development of life. The planet's position within the habitable zone further amplifies its potential, as it could theoretically allow for the presence of liquid water, a critical ingredient for life as we know it. While its exact atmospheric composition remains a mystery, ongoing research continues to explore whether it could retain an atmosphere dense enough to regulate temperatures and sustain water on its surface. Lytton B's relatively close proximity to Earth also makes it an attractive target for future exploration, as studying it could yield insights into the factors that make a planet truly habitable. Though much remains to be discovered, Lytton B stands as a testament to the vast possibilities the universe holds, reminding us that even among the countless stars, there may be places not so different from our own. As the sun rises on the next chapter, let us take a moment to reflect on the incredible variety of planets we have explored throughout this journey. Each of these worlds, from Proxima Centauri b to Lytton B, carries unique characteristics that make it a candidate for habitability. Some stand out due to their location in the habitable zone, where conditions might allow for liquid water, like Kepler 186f and TRAPPIST-1e. Others intrigue us with their size and composition, such as the super-Earths Gliese 667 cc and HD 40307g, planets that might possess rocky surfaces and dense atmospheres capable of supporting life. There are also those whose atmospheres spark curiosity, like K218b, where the detection of water vapor hints at complex environments waiting to be understood. Then there are planets like Captain B, whose ancient age challenges us to ponder what a world so old might reveal about the longevity of habitability. Each discovery represents not just a scientific achievement, but a step closer to answering fundamental questions about our place in the cosmos. These planets, with their diverse traits, serve as a reminder of the vastness of possibilities that lie beyond our own solar system. The mysteries surrounding these worlds persist, fueling the scientific quest to uncover more. Future technologies and missions might one day provide us with deeper insights, allowing us to analyze atmospheres, surface conditions, and even detect signs of life. The universe is vast and filled with secrets. Among the billions of stars, perhaps there are more planets yet to be found, ones that could redefine our understanding of habitability and what it means to call a place home. With so much still to explore and learn, the possibilities are as infinite as the cosmos itself. As we draw this incredible journey to a close, the possibilities of habitability among these 30 fascinating planets remind us of humanity's unyielding quest to find a future beyond Earth. Each world we explored, from the closest neighbors like Proxima Centauri b to the ancient Captain B, holds a piece of the puzzle in the search for a second home. These planets, with their rocky surfaces, dense atmospheres, temperate zones, and even traces of water vapor, ignite hope and curiosity. They challenge us to think beyond the confines of our solar system and envision what lies ahead in the vastness of the cosmos. This pursuit is not just about survival, it is about expanding the boundaries of human knowledge, ensuring the continuity of life, and daring to dream of a universe where humanity thrives among the stars. The wonders of modern science have brought us closer than ever to answering monumental questions about life beyond Earth, but the journey is far from over. So we ask you, which of these planets do you believe could be humanity's second home? Could it be the watery worlds like K218b or Kepler 186f, or perhaps the ancient mystery of Captain B? Share your thoughts in the comments below, and together, let us continue the conversation about our place in the universe. If you enjoyed this exploration, don't forget to like, subscribe, and hit the notification bell to join us on more journeys beyond the stars. The universe is waiting, and the next discovery might just be around the corner.